I recently sat down with a senior manufacturing strategist, a veteran who has spent decades optimizing supply chains for top-tier Korean and American firms. He was radiating confidence, walking me through their latest semiconductor roadmap. He pointed to the R&D budget, the patent filings, and the sheer brilliance of their engineering talent. To him, the formula was immutable. We have the smartest minds, so we win the market. He spoke with the absolute certainty of someone who believes the world still runs on the rules of 2010. But then I shifted the conversation. I didn't argue with his tech specs. Instead, I slid a single image across the table, a sales listing for a fully functional electric vehicle priced at just $900 sitting on a European street. The change in the room was immediate. The confidence evaporated. He stared at the price tag, then looked back at his R&D charts, and you could see the cognitive dissonance hitting him in real time. He started stuttering about substandard quality and dumping practices, trying to rationalize how a complex machine could cost less than a high-end smartphone. He was looking for a technological explanation, but he couldn't find one. That silence, that inability to compute the number, revealed the invisible crisis facing Samsung, Europe, and the US. He was obsessing over the brain of the industry, the chips, the code, the patents, while completely missing that the skeleton underneath has been replaced. Watching him struggle to explain that $900 car made one thing terrifyingly clear. The old powers aren't just losing a trade war, they are fighting a structural war they don't even realize has begun. Welcome to the deep dive. That image, a road-ready electric vehicle selling for the price of a mid-range laptop, is, I think, the perfect symbol for the monumental challenge we're diving into today.
It really is. Because it's not just about trade, is it? Or even just about EVs.
Exactly. This is about a fundamental a structural rewrite of the rules of global manufacturing power. Our mission today is really to unpack this shift.
Yeah, this idea that the competition is moving away from just pure tech innovation, what we're calling the brain.
Right, and moving toward the ruthless optimization of the industrial systems, the framework, the skeleton that lets innovation actually get built.
And not just built, but built affordably, predictably, and at a massive, massive scale.
That framing is so essential, and I think it gets to the heart of why so many strategists are just struggling right now.
Well, for 50 years, the West, Japan, South Korea, they all operated on this sacred assumption that intellectual property and cutting-edge design, the brilliance of the brain, was the ultimate decider.
If you had the best chip, you won. Simple as that.
If you had the most advanced chip, the most patented process, you won the market, period. But that $900 EV, it doesn't just challenge that idea.
It ends it.
It effectively ends it. It proves that technical brilliance can be, completely outpaced by a superior industrial architecture.
So you might have the smartest mind in the world.
Right. But if your body, your structural system, is slow and it's fragmented and it's astronomically expensive to run, you are going to lose the global industrial race.
And that's the structural shift, the one that's redefining the entire economic hierarchy.
Okay, let's unpack that cognitive dissonance we hit right at the top. For decades, billions were poured into R&D labs because the formula seemed so simple.
Innovation wins.
Innovation wins. So why is the $900 car the ultimate grenade thrown into this belief system? I mean, what are the immediate, cold, hard data points that just show this is a different set of physics?
The data is.
Yeah.
It's not just compelling, it's catastrophic for legacy players.
Yeah.
Especially when you look at scale and cost. The sheer volume difference is just, it's impossible to rationalize away.
Give us the headline number.
Okay, so China currently produces 34 times more electric vehicles than South Korea.
34 times. 34. This is not a minor market adjustment. This is an entire industrial ecosystem running at a magnitude of velocity that traditional leaders just cannot comprehend, or at least they can't replicate it quickly.
And it's not just the final product, right? The cars themselves. This structural advantage, it goes all the way down.
It penetrates every single level, especially the core components. You have to talk about batteries.
Let's talk about batteries. The sources highlight CATL. For anyone who doesn't know, CATL is contemporary Amperex technology. They're a global battery giant.
The giant. And when you look at their pricing, they're selling batteries up to 60% cheaper than their Korean competitors.
60%. And the crucial point here is that this isn't because of some secret new technology, is it?
No, not really. It's attributed less to some unpatented technological leap and far more to the structure of their production and their supply chain.
Precisely. CATL's advantage comes from things like vertical integration and hyper-localization, which I know we'll get into.
Oh, absolutely. They control the whole process, from digging the raw materials out of the ground to refining them to assembling the battery packs. And it all happens within these highly localized, government-supported clusters.
And that structural efficiency just crushes costs, logistics, waste, time to market.
It drives them down dramatically. I mean, if you can shave 60% off the single most expensive component of an EV, the battery, just by improving your structure, well, then the race for a slightly better battery chemistry becomes secondary.
It's secondary to the raw economic leverage you get from your superior architecture.
Exactly.
And that economic leverage translates directly into just blinding speed. I think the time compression metric is maybe the most alarming for established car makers.
Like Detroit, for Stuttgart, for Tokyo.
Yeah.
New Chinese EV brands are moving from an initial concept sketch to full mass production in a breathtaking 18 to 20 months.
18 to 20 months, and the comparison.
Well, you contrast that with the established Korean, Japanese, and European brands. They typically need somewhere between 36 and 48 months to do the same thing.
So you're paying a time tax, a 50% time tax, just because your internal structure is slow and fragmented.
And that inefficiency is built into their history. It's how they've always operated. Legacy automakers have supply chains that span entire continents.
Right.
They have fragmented regulatory approvals in different countries and just massive internal bureaucratic inertia.
So when a competitor can cut your time to market in half,
They double their learning rate. They double their iteration cycles. And they radically reduce the cost of making a mistake.
Yeah.
And this structural advantage, that's what we're calling the invisible war. It's happening beneath the surface of all the talk about tariffs.
So we need to formalize this concept, the idea that technological brilliance is no longer enough. What's the governing principle here? Why are the world's best engineers losing this race?
We can frame it using a concept called the beyond view principle. And it's simple. The best engineers ultimately lose to the best structures.
The best engineers lose to the best structures.
That's the central idea rewriting the global manufacturing hierarchy. We have to stop seeing this as just a technology race. It is now fundamentally an architecture war.
And the winner of that war.
The winner of the architecture war controls the price floor and the speed of innovation for the entire global market.
But let's play devil's advocate for a second. For decades, the West's strength was supposed to be its decentralized structure, right? Free markets, different regulators, specialized companies, all competing.
Sure, that was the theory.
So doesn't a highly centralized, streamlined system create single points of failure? What about resilience or creativity?
That's a critical and totally legitimate challenge.
Yeah.
But the core failure of the legacy structure, I would argue, wasn't decentralization itself. It was fragmentation and high friction.
What's the difference?
Well, every border you cross, every separate regulatory body you have to please, every 5,000-mile shipping lane, that all adds cost and it adds friction. It slows you down. The new structural advantage aims for integrated efficiency, not fragmentation. It maximizes speed and cost control. And it addresses resilience through massive scale and redundancy within the local cluster, not by spreading things out across the globe.
So the system is designed to accelerate processes and just minimize that friction. It turns a historical weakness, a scattered supply chain, into a modern strength, which is localized control.
You've got it.
That makes perfect sense. So let's define this winning architecture, this new skeleton. Our sources point to 4 foundational pillars that hold this whole thing up.
Right. This industrial architecture, it's built on 4 interconnected pillars. They reinforce each other, and they generate this unstoppable industrial metabolism.
And they are.
They are cost, speed, scale, and energy.
Looking at that list, cost and scale have always been part of manufacturing, but speed and energy, that feels like the real pivot away from the old focus on, say, cheap labor.
Absolutely. Speed is all about achieving what we call regulatory velocity. It's about reducing that time tax on every single cycle and accelerating iteration. This is a deliberate policy advantage.
And energy.
Energy, crucially, is the recognition that modern high-value manufacturing, we're talking AI, advanced chips, battery cells, it is intensely power-hungry. If you don't have vast, cheap, and stable electricity, you simply cannot host these industries at the scale required.
The country that solves the energy problem fundamentally sets the global cost for the product.
That's it. And the unavoidable truth that has to guide every boardroom decision now is this. You can have every patent, the most advanced chips, the smartest people. But if your industrial structure is too slow, too fragmented, or too expensive,
If your industrial architecture is weak.
you are structurally optimized to lose manufacturing power. The strategic game has completely shifted from chasing technological brilliance to fundamental structural reform.
Okay, let's start with how geography has been almost weaponized to crush costs and exponentially amplify scale. We're talking about the shift from continental sprawl to these hyper-localized clusters.
Right, and this idea of the 3-kilometer city is maybe the best way for you to really grasp the depth of this change.
It's a great anecdote. Let's walk through it. Consider the story of Hans, a senior procurement director for a big German automotive firm.
Right. He's visiting an industrial park in Chengdu, auditing a potential supplier for their new budget EV line.
And during a critical review, they find a flaw, a tiny 2-millimeter flaw in a prototype battery casing.
Now, in his German mind, this is a catastrophe. It's a red alert.
He's thinking 2 weeks of lost production, complex redesign emails flying across time zones.
And then waiting weeks for a new sample to arrive on a ridiculously expensive air freight shipment.
But the reality Hans experienced was, well, it was a moment of profound realization about this new architecture.
The local factory manager didn't panic. He didn't even open a laptop to file a ticket.
What did he do?
He just picked up his phone and called a supplier named Wei. And Wei's factory was located just 1.5 kilometers down the road. You could literally see it from the window.
So Wei arrives on a scooter in 20 minutes.
20 minutes.
Yeah.
He takes the bad casing, he immediately understands what needs to change, and by the time Hans is done with his lunch break,
The redesigned, perfectly fitted part is back on the assembly line.
that instant resolution,
Yes.
that is the entire competitive advantage in a nutshell.
Hans wasn't competing against a single factory. He was competing against an entire industrial ecosystem that was compressed into a 3-kilometer radius.
And when your whole supply chain is hyper-localized like that, your logistics costs just plummet. They go to near zero.
Yeah.
And your iteration speed, it stops being a luxury. It becomes an instant low-cost necessity.
That is the cluster effect in its purest form.
It is. And it's not just a few factories. It's thousands of specialized suppliers all nested together. They provide redundancy, and they drive logistics costs into the marginal realm. The cost of iteration, which is the most vital factor for rapid hardware development, is reduced to the price of a local scooter ride and a quick chat.
And the scale just amplifies this effect.
It makes failure cheap, it makes learning instant, and your production predictability just skyrockets.
We see this across these massive geographical hubs, right? Like the Greater Bay Area.
The GBA, yeah. The Guangdong, Hong Kong, Macau, Greater Bay Area. You're talking about a region with over 75 million people. It's a globally unique convergence zone.
And Shenzhen is at its heart.
Shenzhen is where the software, the hardware, and now, increasingly, the AI solutions all intersect in one single high-speed ecosystem. And this is exactly why huge global corporations, Airbus, ABB, Microsoft, Dell, have anchored their advanced innovation centers there.
They need that instant access, that proximity to a complete supply base to shrink their own R&D cycles.
They have to. And the sheer physical scale it's almost incomprehensible if you're used to a Western industrial park,
We're talking about mega clusters in provinces like Jiangsu, Guangdong, Shandong.
where you can have more than 800 EV-related factories, from giant battery producers to tiny little component molders, all located within a single hour's drive in one province.
And when scale gets to that level, it becomes an economic moat.
An impenetrable one. It attracts more investment, it pulls in specialized talent, it reinforces the supplier base, and you get this virtuous feedback loop of hyper-efficiency.
So Shenzhen has evolved. It's moved up the value chain.
It's strategically shifted its focus toward R&D and high-end innovation, absolutely. But at the same time, it maintains its crucial role as the world's most sophisticated supply chain solution center. That integration ensures the cost and scale pillars of the structure are just constantly being optimized.
But let's go back to that robustness challenge. If you have 800 factories all clustered in one region, what happens if there's a big localized disruption? A natural disaster, a power outage?
That's a fair question. It sounds like putting all your eggs in one giant basket.
Right.
But the system relies on deep redundancy and horizontal specialization within those clusters. So, for example, if one factory that makes a specific type of metal stamping goes offline in one part of Chengdu,
There are others nearby.
there are usually 3 or 4 other comparable competitive suppliers within a 50-kilometer radius, right there in the same cluster. The network is so vast and deep, the Tier 2 and Tier 3 suppliers, that a single failure doesn't cripple the whole chain. Resilience is built through competition and immediate substitution, not through geographical separation.
Okay, let's pivot now to that second critical pillar, speed. This is where the old powers pay this debilitating time tax because of all the bureaucratic and regulatory friction.
While the new structure moves at what we're calling regulatory velocity. And you have to look at how that institutional friction just incinerates individual brilliance.
Let's use another hypothetical. Think about Minho, a brilliant Korean battery engineer.
Right. He's pulling 80-hour work weeks. He's pushing the boundaries of solid-state battery tech. His team has a genuine breakthrough.
But his entire project, which is worth billions in potential revenue, is just frozen.
Frozen for weeks, waiting for a single safety certification from a government ministry. And it's a bureaucratic process that requires a standardized 90-day review period.
Regardless of the urgency.
Regardless of the urgency or the promise of the technology. And that delay is economically devastating in a field like batteries, where chemistry is improving almost quarterly.
And the contrast is just terrifying.
It is. While Minho's brilliance is stuck in a holding pattern, his competitor in a nearby cluster, a startup that barely existed 3 years ago, has already built 3 successive versions of a similar battery.
They've tested them, failed with 2.
Learned from those failures instantly, and moved the successful 3rd version into mass production.
So the harsh lesson is, the 80-hour work week and the technical genius are effectively canceled out by the 90-day government certification.
The best brain is paralyzed by an arthritic skeleton.
So how is this radical speed in iteration and deployment formalized? How is it achieved?
This systemic speed is achieved through a methodology we can call Sinovation. It's a fusion of rapid iteration, massive scale, and proactive regulatory support.
And a core part of that is this idea of DevOpsXDFM.
Right. DevOpsX designed for manufacturing, applied to the physical world. Traditionally, DevOps is about software deployment. But in the hardware world, the stakes are exponentially higher.
Because you can't just fix a bug with a software pad.
Exactly. The cost of changing a physical mold or recalibrating a production line is infinitely more expensive and time-consuming than changing a line of code.
So this is about taking that collaborative, fast feedback culture of DevOps and pulling the physical manufacturing engineers into the process right from day one.
Right, from the earliest stages of design. And that integration, the DFM, is so absolutely critical for compressing hardware speed because it minimizes the time spent on process execution, and it injects certainty into new ideas. In hardware, finding a defect early is everything. If you find a critical flaw in your manufacturing process 6 months down the road, you might have to restart the whole project.
But DevOpsXDFM uses advanced simulation, digital twins, process modeling software.
To virtually test the manufacturability of a component before any expensive physical tooling is ever cut. You reduce your reliance on physical prototypes. This dramatically accelerates the learning curve, it shrinks the time to market, and critically, it lowers the cost of failure.
So while Minho is waiting for a piece of paper, his competitor is already using predictive maintenance algorithms and CI/CD pipelines, not just for the software in the car, but for the manufacturing process itself.
Exactly. When the manufacturing engineering team is involved from day one, they are basically hard-coding the experience of the shop floor directly into the initial design. And the regulatory process, which is fueled by state guidance, often moves in parallel with this DFM process.
So factory approvals that might take 6 months or a year in developed economies
are typically resolved in China in just 3 to 8 weeks. And that creates a significant and sustained advantage in time to market.
We have a great, tangible example of this speed in action. It shows just how quickly this model can industrialize and standardize an innovation.
Yes, look at the case of a major global furniture company in Europe. They wanted to test an innovative 3D augmented reality solution for their retail stores.
Oh, okay.
They proved the concept with a small trial in Europe. The Chinese team, leveraging that local manufacturing ecosystem and easy access hardware you can just get online, implemented the identical solution in their big chain stores in just 3 months.
3 months. And what were the results of that rapid rollout?
The results were immediate and quantifiable. That 3-month execution speed proved a 20% increase in sales revenue per customer.
Just by providing a better visualization experience.
Right. And what's more, it slashed the sales assistant's time spent on each transaction from 25 minutes down to just 10 minutes. This whole model is about using speed to test, standardize, industrialize, and then deploy a solution globally.
Making the total cost of ownership actually feasible.
Precisely. That approach bridging design and manufacturing teams enabled by high regulatory velocity, that's the key to reducing friction and accelerating global deployment.
Okay, let's shift our focus to the final pillar. The old playbook said manufacturing was about finding cheap labor. The new playbook makes it clear manufacturing is an energy business.
It is. The world's industrial map is rapidly realigning itself around the availability of vast, stable, and critically cheap electricity.
And the story of Sarah, an American site selection consultant, really crystallizes this shift. Her job was to evaluate bringing large-scale manufacturing back to the U.S.
And she was comparing the operating costs for a new facility in the American Midwest versus expanding an existing one in Shandong province.
Labor costs were starting to narrow, tech costs were identical. But the entire profit margin for the U.S. venture was structurally eaten up by one single line item.
The utility bill. The difference Sarah found was just staggering, and it's deeply foundational. In Shandong, the industrial electricity was fixed at a price approximately 45% lower than her best American option.
And that stability and abundance of energy is the new foundational currency of high-value industry.
It is.
Why is that 40 to 45% difference so fundamentally uncompetitive for legacy markets like Korea or Japan or Europe?
Because energy is the core, non-negotiable input for every single high-value, high-tech sector. You want to train a massive AI model.
You need immense power.
Advanced chip fabrication. You need an uninterrupted, stable energy source.
Right.
EV battery production, from refining the raw materials to running the gigafactories, is profoundly energy intensive.
Same for steel, chemicals, massive data centers.
All of it. So if your foundational input is 45% cheaper and more stable, the tech race for marginal gains becomes secondary. The price gap is structural. It's predetermined.
Which explains the strategic investment in energy abundance.
Absolutely. China's total electricity consumption has grown by the equivalent of the entire U.S. consumption in just 11 years.
That's an incredible statistic.
And this massive sustained growth is supported by strategic and reliable investments in stable energy sources, including advanced nuclear power and utility-scale renewables. That's what fuels their manufacturing dominance.
And it's not just the price and the volume of the electricity, it's the way policy is used to reinforce this structural advantage. Things like subsidies.
Precisely. We have to acknowledge the significant direct policy support and the subsidy structure that props up the whole green tech ecosystem. For example, direct subsidies to a massive, globally competitive company like BYD rose substantially. They reached 2.1 billion euros in 2022.
And structurally, what do those subsidies do?
They ensure the local ecosystem can absorb risk and expand scale, which further leverages the already cheap energy supply. This structural investment in both energy infrastructure and technology creates a cost advantage that is nearly impossible for competitors with expensive, fragmented, and often fossil fuel-dependent grids to overcome.
So Sarah's analysis really holds a key insight. Manufacturing is no longer dictated by who has the most workers or the cheapest labor.
It is fundamentally about who has the most joules of energy per dollar.
And the country that has built the energy skeleton to support advanced manufacturing is now setting the global price floor, which is what allows a product like the $900 EV to even exist.
Yeah.
We've laid out the 4 pillars of this winning industrial structure, but this structural revolution wasn't, it wasn't organic. It was catalyzed by a deliberate, long-term strategic policy framework.
Right. And that brings us to Made in China 2025, MIC 2025. This plan, which was signed back in 2015, was designed to fundamentally transform the country from being the low-tech world's factory
into a self-sufficient, technology-intensive powerhouse.
And that transformation was rooted in ambitious, measurable goals. MIC 2025 aimed to upgrade manufacturing capabilities and aggressively increase the domestic content of core components and materials to 70% by 2025.
And this wasn't a cheap ambition.
Not at all. The initial commitment was around $300 billion, with at least another $1.4 trillion strategically invested in the years following, especially after COVID, focusing on infrastructure and high-tech sectors.
And while the phrase MIC 2025 has been kind of toned down in public,
the policy framework, the funding, and the objectives are all still fully operational.
So with that astronomical level of coordinated investment, how successful has it actually been in shaping the structural reality we're talking about today?
By most metrics, the program has been overwhelmingly successful. One analysis of the plan found that 86% of the over 260 original goals had either been achieved or are significantly ahead of schedule.
And you see the impact in global market dominance in key emerging sectors.
You do. Can we elaborate on the 5 critical technologies where global leadership has now been solidified? Okay, so the country has achieved global dominance in 1. high-speed rail with the most extensive and advanced network in the world.
Okay.
2, graphene, leading in research and applications, especially in battery tech. 3, unmanned aerial vehicles, or drones, complete control over that manufacturing supply chain.
Right.
4, solar panels with dominance in polysilicon and wafer production. And 5, electric vehicles and lithium batteries, the key sector we're looking at today.
And beyond those 5.
Specific sector goals in things like industrial robotics, advanced agricultural machinery, biopharma, and marine engineering have all been fulfilled or surpassed. It shows a really comprehensive structural transformation.
This policy-focused, state-guided capital and tax breaks on 10 key industries. What are the core sectors that the government strategically accelerated?
These 10 industries really form the bedrock of this modernized economy. You have advanced information technology, which includes AI and the Internet of Things. Right. Then robotics, green energy and EVs, aerospace, ocean engineering, railway equipment, power equipment, new materials, medicine and medical devices, and advanced agriculture machinery.
And the acceleration was achieved through things like state-backed venture funds, tax holidays, and land use mandates designed to create those clusters we talked about.
Exactly. And beyond the funding, there was a crucial geographical component to this. Manufacturing capability is no longer just concentrated in the old coastal hubs. It's been purposefully decentralized into highly specialized national industry clusters across the interior of the country.
And that decentralization is a key part of achieving full national scale.
It is. While the historic coastal hubs like Shenzhen and Shanghai have evolved their focus to R&D and high-end innovation, they're still the command centers for complex supply chains. The inland hubs have been systematically developed into powerful, specialized manufacturing centers,
offering targeted government incentives and access to newly trained, skilled workforces.
Precisely.
So where specifically are we seeing this inland specialization emerge?
A prime example is the emergence of Chengdu and Chongqing in the western region. They've become really strong technology hubs, specializing in electronics, AI solutions, and semiconductors.
And how did that happen?
Through aggressive talent migration programs, significant government incentives for major manufacturers to move production lines inland, and massive infrastructure expansion, especially rail links, to ensure logistics connectivity.
And other cities.
Wuhan focuses heavily on automobiles and large-scale equipment manufacturing. And cities like Xi'an and Lanzhou are benefiting from infrastructure expansion linked to strategic initiatives, connecting them more directly to key transport routes.
Let's break down the hyper-specialization into a few specific industry clusters, just to show how integrated this system is. Let's start with electronics and the IC sector.
Okay, the electronics sector is a perfect illustration of tiered specialization. First, you have the Yangtze River Delta, with Shanghai and Jiangsu. That's the strong industrial base, making laptops, consumer electronics, and it's a hub for semiconductor fabrication.
Okay, that's tier 1.
Then you have the Bohai Economic Rim around Beijing. That's strategically positioned as the major R&D and distribution hub, specializing in communications and software design.
The brains.
In a sense, yeah. Third, the Pearl River Delta Shenzhen and Guangdong. That area leads in IC design and rapid prototyping, leveraging that intense hyper-localization we discussed. And finally, the Western cluster in Chongqing has emerged as a major secondary electronics hub.
The specialization ensures the whole value chain from design to fabrication is covered nationally.
It optimizes the entire system. And you see the same focused development in the auto sector, especially new energy vehicles.
Right.
The automotive structure has solidified into 6 major national clusters. The Yangtze River Delta cluster is heavily focused on NEVs, with leaders like SAIC and Geely.
And the Pearl River Delta.
That cluster, including the behemoth BYD, has specialized in intelligent and connected vehicles, really leveraging Shenzhen's IT expertise. And the Western cluster, anchored by Chang'an Automobile in Chongqing, uses that region's industrial strength for large-scale production.
Each cluster contributes something distinct. It prevents redundant investment and maximizes the collective advantage.
Exactly. And one last one, biopharma, another core MIC 2025 industry. You see clusters nested within national high-tech development zones right next to research universities. The Yangtze River Delta has a major concentration in Shanghai's Zhangjiang Science City.
R&D and venture capital.
Right. And Guangdong has the Guangzhou International Biotech Island. This entire process is actively supported by comprehensive strategic plans, like the 14th Five-Year Plan for Bioeconomy Development, which explicitly mandates the deep integration of biotech with IT and AI.
So again, it's aligning the brain with a highly effective skeleton.
Always.
The electric vehicle and automotive industry really gives us the single best, most quantifiable case study for how this structural blueprint cost, speed, scale, and energy all converges to achieve just decisive global market dominance.
The data points are a stark confirmation of a structural victory. China has been the #1 auto market globally since 2009. It now accounts for 34% of global vehicle production.
And it leads the world in new energy vehicle sales.
It does, with domestic Chinese brands holding an overwhelming 80% share of that huge domestic market.
But the most critical benchmark, the one that really signals the shift,
is that since 2023, China has been #1 in auto exports. It surpassed Japan. And that export growth is driven heavily by NEVs, targeted toward emerging markets, and increasingly Europe.
And this dominance isn't just about assembling cars, it's about controlling the underlying components that are necessary for the entire clean energy transition. The control over the supply chain is almost total.
It's an anchored structural advantage. They control the foundational components that will define the future economy. We're talking 90% of the world's polysilicon for solar.
Wow.
0.80% of lithium-ion batteries, and 70% of rare earth magnets, which are critical for high-efficiency motors in EVs and wind turbines.
So that supply chain control allows giants like CATL and BYD to set global standards.
And, critically, to relentlessly drive down costs. The result is just massive export volumes. For example, $65 billion worth of lithium-ion batteries exported in 2024 alone. It cements the country's role as the indispensable global supplier.
The speed and cost of this model are so disruptive that analysts are now describing the global auto industry as fundamentally fracturing into 3 worlds.
That's the major consequence. The China speed model and its integrated ecosystem logic are now setting the global agenda.
Okay, walk us through the 3 worlds.
World 1, or W1, is the China-led digital ecosystem. It's defined by digital platforms, strong public sector involvement, and vehicles that are conceived from the ground up as connected, networked products providing services. This is the pacesetter environment.
Okay, then World 2.
W2 is the legacy markets, Europe, North America. These markets are rooted in traditional owner-driver models, mostly private sector-led. Electrification is happening, but it's uneven, and it's often burdened by high R&D costs and overinvestment in old combustion engine infrastructure.
And finally, World 3.
W3 is the battleground markets. These are the emerging economies, and they are intensely price-sensitive. Analysts project they will be overwhelmingly dominated by Chinese OEMs by 2030, purely because of that structural cost advantage from their integrated supply chains.
So the model is exporting its standards, its speed, and its cost logic globally.
Especially to regions where affordability is the #1 purchasing driver.
Which forces established global players, firms like Autoliv, Magna, Aptiv, to make a radical pivot. They can't survive anymore with those old arm's-length supply relationships.
No, they have to adopt what's being called the high road strategy. They have to deeply embed themselves into the structural ecosystem.
So how are these legacy suppliers adapting? How are they surviving or even thriving?
They're realizing that trying to compete against the structure is futile. They have to leverage it. The high road strategy has 3 principles: deep localized R&D, leveraging complementary strengths, and matching China's speed.
They have to co-develop with local firms and basically use China's speed and scale to accelerate their own global product lines. Let's break down the Autoliv case. They're a massive safety systems supplier. How did they position themselves as a bridge?
Autoliv made a decisive move. They anchored their chief technology officer and their core R&D functions directly in China, not just their manufacturing. They went from just supplying standardized parts to actively co-developing safety components like ECUs and advanced seatbelts directly with local Chinese Tier 2 suppliers.
Which ensures their tech integrates perfectly with the ultra-fast-moving digital architecture of the Chinese OEMs.
Right. Companies like BYD now highlight Autoliv as a key safety partner. And the key outcome here is what they call reverse exports of innovation.
Explain that.
Innovation is refined and accelerated in the Chinese ecosystem, where the speed demands are highest and the iteration cycles are compressed. Then these technologies are deployed back into Autoliv's global portfolios for Europe and North America.
They're using China's structural speed as an R&D lab to maintain their own global relevance.
That's a perfect way to put it.
Magna, another huge global supplier, had to pivot their entire business model even more dramatically.
Magna's shift was about pure strategic survival. Their revenue from local Chinese OEMs went from a negligible share to a staggering 60% by 2024.
And to adapt, they had to internalize those relentless demands for shorter lead times and constant cost reductions.
Their technical response was massive modularization. They started turning complex components into standardized, platform-based solutions that really reduce complexity and cost for the OEMs. And crucially, they now use their global footprint as an asset. They position themselves as an international bridge for Chinese partners who are looking to expand abroad into those W2 and W3 markets.
And finally, Active. They seem to exemplify the ultimate fully embedded strategy in China, for the world.
Aptiv took integration to the extreme. This included equity investments, like an 18% stake in the Odessa developer Max-I. They invested heavily in localized R&D and manufacturing centers that are dedicated to this hyperspeed environment.
And the outcome is a suite of China-developed technologies.
Right. Things like advanced radar vision, fusion, and complex hypervisor systems, all developed and validated at China speed.
Wait, for the listener, what exactly is a hypervisor system in this context?
Okay, so a hypervisor is basically a virtualization layer. It lets multiple operating systems run safely and securely on a single piece of hardware. In a smart car, this is vital.
Why?
Because you need to run distinct systems, say the demanding infotainment system, which might run on Android right alongside the mission-critical systems like your driver assistance or braking, which need super robust, safety-certified software. And you need to do it all on the same central computer.
So developing these systems locally and quickly is critical for intelligent vehicle architecture.
It is. And the most important metric of Aptiv's success is that these China-developed technologies are competitive on a global scale.
Absolutely. These locally developed technologies actually qualify for European NCAP pre-certification.
And NCAP is a new car assessment program, the safety rating system used across Europe. The fact that technology developed to meet the domestic China speed requirement is robust enough to pass strict international safety pre-certifications.
Yeah.
It illustrates the core point.
The structural environment is so demanding and so effective that the innovation it produces is inherently globally competitive.
Exactly. These companies realize that if they cede ground in China, they risk eroding their technological and structural relevance everywhere else in the world. Hashtag tag outro.
So we've dissected how that $900 EV symbolizes the complete victory of a structural model over the old technological model of the past. The structural war is being won not in the most advanced labs, but by the most ruthlessly efficient industrial architectures.
That's right. And to synthesize this fundamental shift, manufacturing supremacy in the next decade is going to be determined by 5 interconnected factors.
Okay, let's listen.
Electricity, speed, scale, structural control, and AI acting as the central nervous system of production.
Let's quickly break those down.
Electricity is the foundational, indispensable currency for all high-value industries. Speed, or regulatory velocity, dictates the pace of market entry and iteration, and it just incinerates the efficiency gains of any slower competitor.
Scale creates that impenetrable, redundant supply chain moat.
Right. Structural control refers to the deliberate policy framework, like MIC 2025, that aligns capital, talent, and energy resources toward a singular goal. And AI is rapidly integrating into the production process, not just in robots, but in predictive maintenance, advanced logistics, and demand forecasting.
It's the central nervous system that makes the whole structure smart.
And it makes any factory or supply chain that can't leverage that data-driven system completely obsolete.
So what does this analysis mean for you, the investor, the strategist, or the business leader listening? The key takeaway is simple. You must stop obsessing over technological brilliance as the sole measure of competitive advantage.
You have to start studying the structural indicators of the future.
The next generation of trillion-dollar companies will not simply come from the regions with the best labs. They will come from the regions that have built the best structures.
That's the new reality.
The world is aligning manufacturing around energy and speed. Understanding the structural change is the only key to navigating the future economy. That means shifting your focus away from the latest chip patent filing and starting to analyze industrial electricity stability and cost, regulatory approval cycle times, and the granular proximity of specialized supplier clusters. The future of manufacturing will be shaped not by the countries with the best ideas, but by the countries with the best industrial architecture. The structural war has begun, and the rules of the game have been permanently rewritten.